Okay, so let's have a look at the key things that stand out to me in this question so I can see that's a content question. So it's just a 1 mark. It's going to be about recalling some kind of content about this topic. And what's it told me? So it says that a long time ago, scientists believed that Earth was at the center of the solar system. So people used to think that it was geocentric. Now what it's telling me is that there's the sun at the center. So now it's going to be heliocentric. But I've got to be careful here because the question is asking me, it says give one other idea about how the solar system has changed over time. So I can't be getting marks for using the words geocentric or heliocentric, even though um, like I might want to use those for future questions. I should still know those terms. But I'll just be careful here about another idea. So I can't say anything about the sun being in the center of the solar system. So what can I say then for this question? Just any other ideas about the solar system that's changed? Now, one other thing that I've got to be careful here is that it's saying solar system. So what some students will be talking about here, just remembering the astrophysics topic, is going something about redshift or the Big Bang or steady state or the expanding universe and all that kind of stuff. So that's an idea about the universe that's changed. They're all ideas about the universe that are changing. So like Big Bang theory over steady state theory, that's not to do with the solar system. So I've got to be careful that I'm mentioning stuff that's specifically in the solar system, but it can't be about heliocentric. So what other things do we know? Well, we know that planets have got moons now. We know that the Earth is spinning, and there's literally anything that I can say. So I'm just going to say 2 or 3 things: spinning or rotating. Because then if I get one of them right, as long as they're all true and one of them's on the mark scheme, I've got the mark for it. So Pluto being a dwarf planet rather than a actual planet, so it's been like declassified as a planet. So I can say any of those things. I know that this is true. All of these things are true, so I'm not going to be losing any marks, and I'm pretty happy that I'm going to get them. So for part A to this question, this is just content for if you're doing triple. Part 2 to it, so this part over here is an unfamiliar equation, which if you're doing combined or triple, you should still be practicing it. But for part A, it's recall of content, and it's content that's just for triple. So let's have a look at what the thing is. So what's the key thing? It's telling me it starts off as a nebula. So what do I know anything about a nebula? And then it says describe the process that occurs to produce the conditions necessary for fusion in a star. So I'm going to have to mention something about a process. Process just means this happens and that happens and that happens. And I've got to link it to fusion. How is that related to fusion? So if I know that it starts off as a nebula and it says what's the process, I just need to know my content about the stages of the life cycle of a star. So what happens after a nebula? Well, I know that a nebula is going to collapse, and this is always a separate marking point. It collapses due to gravity. And saying about it collapses due to gravity is always a separate marking point. So I'm going to make sure that I'm saying that. So now this is probably 2 marks. It might be 1 in certain exam schemes, it might be 2 in others, but it could be 1 for saying collapses, 1 for saying gravity. It could be that some mark schemes are more strict and you just have to say collapses due to gravity. So if I don't say gravity, I'm definitely losing the marks. I'm make sure I'm going to say it. So it collapses due to gravity. Now, what do I know that happens when things collapse due to gravity, or when things are under the influence of gravity? They're basically falling down. Well, if they're falling down, I know there's energy transfer in there as well. So because there's keywords for energy, again, I'm going to make sure that I'm linking that. So the fact that I have said it collapses due to gravity, whenever anything goes collapses due to gravity or falls down due to gravity, it's always the GPE is going to be converted to kinetic energy. So that's the process that's sorted, because now this is when fusion can take place. So I'm going to say why, how does this actually relate to the conditions necessary for fusion? Well, I need fusion. I know that fusion needs high temperature and high pressure. So I'm just going to make sure that I'm saying that. And then, well, how does this relate to high temperature and high pressure? That's making an arrow pointing up, keep changing it. Well, it's because if there's a lot of kinetic energy, a lot of kinetic energy means that it's high pressure. A lot of kinetic energy means it's high temperature. So high KE means high temperature and pressure. I've definitely got full marks here. Even if this was like a 4-mark question, I've probably said enough for 4 marks as well. So the next part is one that, whether you're doing, even though it's in an astrophysics topic, it doesn't matter, it's an unfamiliar equation. So they can ask in any topic, combined or triple. So either, whichever paper you're doing, make sure that you understand in this. Okay, so this is nice that they've given me the equation. It says calculate, and it's worth 2 marks. So if I'm in the exam looking at this question, I'm thinking, yeah, as long as I do everything sensible, all the same things in the proper way that I should be doing it, I'm getting 2 marks here. There's nothing that can really go wrong as long as I'm careful. So what is the first thing that I've always got to do? Check the units. So the units here, it says meters per second. I've got second over here. I've got joules over here. I've got second over here. There's nothing there that can really trick me. So in the units, that can trick me anyway. So now I'm writing the formula, E equals mc squared. What am I looking for here? It says the loss of mass, and it says the loss of mass in 1 second. So I'm going to write mass first. And because it says in 1 second, is there anything that I should be like suspicious about, any conversions that I need to do? In the real exam, what might happen is they say the mass in 1 second or 1 minute or whatever, and this time period would be different to this time period. But because in this question, both time periods are the same, I don't need to take into account like, times by 60 if it says by minute or something like that. It's fine. They're both saying per second. So I'm quite happy with this, and that's why it's only a 2 mark question. So have I got energy now? Yeah, I have. So I'm going to write down energy, 3.86 times 10 to the 26. Have I got C? Yeah, I have. It's 3 times 10 to the 8. Now, what do I need to be careful about? There's a square. So whenever there is a squared in there, just make sure that you are like thinking, oh, I better not mess this up, because a lot of students do forget to do squared. I'm going to show the examiner that I know how to rearrange. So I'm going to put 3.86 times 10 to the 26 divided by 3 times 10 to the 8 squared. I'm always showing the examiner that I can rearrange. I'm not just going to rearrange and put straight into my calculator just in case I type something wrong. I've got to make sure that I'm getting my method mark. So I'm going to say that, and then I'm just going to put this into my calculator, and the answer that I'm getting off my calculator, so the mass is equal to 4288888. There's a lot I should have just done it in standard form. I'm going to cross that out and just do it in standard form. So 4.2888 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's the mass. Okay, now I've got to always round to 2 significant figures unless it tells me to do anything different than that. So the answer here would be 4.3 times 10 to the power of 9. And I'm happy that I've got the right answer. Even if I have typed in something wrong, I've made my working so clear that I'm going to get my method marks for it anyway. But I haven't typed anything in wrong. This is the right answer. Okay, so we're on the last question of the paper now, and I'm pretty happy it's a formula question. So as long as I do everything sensibly, I'm definitely going to get full marks for this question. And hopefully you're getting sick of hearing me say the same thing over and over again. But it's just this procedure, drumming this procedure in your head. And when you get a formula question, you should be so grateful. Yeah, good, 3 marks basically in the exam. So first thing that I'm doing is checking for units, and these units are fine. Then I've got to write the formula. It's given me the formula. Now this is an unfamiliar formula for both combined and for triple. It doesn't matter which one you're doing. It's literally just an unfamiliar equation. Just make sure that you're doing it. So write the equation down. So m equals 4 pi times d times r cubed. I've just got to be careful that r is a cubed here. Divided by 3, because sometimes students, like I've said before, will forget to do a square or a cubed or something like that. Okay, so now what am I looking for? I'm looking for r cubed. So I'm going to write down, well, I'm looking for r, sorry. So I'm going to write down r cubed first and just make sure that I'm not going to get tricked for if some questions give me like an irrelevant piece of information or something like that. I'm going to put in the wrong place. Now, have I got an m? I'm going to go from left to right now. Have I got m? Yeah, I have. It's 4 times 10 to the 30. 4 pi is 4 pi. D, have I got d? It says 6 times 10 to 17. 10 to 17. That's it, and it says all divided by 3. So now I'm just going to rearrange it to say r cubed equals first. If you struggle with how to rearrange, obviously make sure that you're asking me so I can help you with it. So I'm bringing the 3 up to the other side, so it's divide on this side, I'm going to bring it up to the other side. The 4 is already out of the way, so it stays where it is. That becomes times 3. This becomes, so those are multiplied on the top, so when they go to the other side, they're going to be divide. So divide by 4 pi times 6 times 10 to the 17. Now remember, when you're putting this in the calculator, just make sure that you're using the times 10 to the power of x button, or the and also the fraction button, just to make it a little bit easier, because students will kind of get this wrong otherwise, or maybe type things wrong in terms of order of operation. So I'm using a fraction button. I'm also making sure I'm using X button, the times 10 to the power of X button, and then I'm just putting that in there, and it says, I'm still typing it, times 6 times 10 to 17. So the answer I'm getting for r cubed is 1.5915 blah 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 times 10 to the 12. I'm writing down a lot of number of significant figures on my calculator, and I'm making sure I'm writing that stage, because now if I get the next thing wrong, well, I could pick up some method marks here. So now it says r cubed, and I'm going to need r, so I'm going to have to take the cube root. So the cube root of that is the symbol on your calculator that looks like that, and on mine it's a shift square root. So I'm going to press shift square root of answer, and I'm going to write the full number down from the calculator, 11675.443 dot dot dot. Okay, so now I'm going to round this to two significant figures, because it doesn't tell me anything that I shouldn't do that. So this to two significant figures is going to be, so there's my second significant figure, so 1 1. So that's a 6 right after that, so it's going to be 1 2, and then these just turn into 0 before the decimal point, 0 0 0. And even if I got this rounding wrong, well, I've written the full answer here, so I should do enough to get the mark either way, but obviously the rounding is right. Yeah, and okay, so this is the end of the question paper, and like I keep on saying, it's not about getting these particular questions right. It's about making sure that you are doing the questions in the way that I'm doing it, and you just keep on doing the questions in the way that I'm doing it. So look at how throughout the paper and throughout all of the questions, I've been taking this exact same approach. When it's a graph question, I do this. When it's a 6 mark question, I do this. Formula question, I do this, and so on. The more you do and the more practice that you're doing, like, there's no way that if you do everything that I do, then obviously you're going to get a grade 9 in the exam, and that is exactly what I want. So just make sure that you're following these videos properly, going over it again if you need to, and just doing everything that I am doing, and then yeah, great. Okay, so I can see that this question is about the astrophysics topic as well, Mercury, Venus, Earth, all the planets I can see from there. However, the main thing that's standing out to me in this question is that it's a graph question. So whether or not you're doing triple is irrelevant, because the skill that's going to be testing is going to be tested on the combined paper, and it's going to be tested on the triple paper. It's something about a graph, so I've just got to do all the same things that I do when I see a graph. I know I'm not going to be happy until I've taken readings from the graph or drawn on the graph or something like that. So let's have a look at what the question says. So I'm going to have to use the graph to estimate the distance of Ceres from the sun. And what information have I got about Ceres? I can see that it is 4.6 Earth years away. So this axis over here talking about Earth years. I need to know the distance. I'm obviously going to have to go from this axis over here and go onto this axis. But what I'm going to need first, I'm going to need the line of best fit. So I'm going to have to draw on this graph, obviously. Now, what some students will make a mistake for here is some students will just assume that every line of best fit has got to be a straight line with a ruler. Some people will do dot to dot. Both of those things in this situation aren't right. A line of best fit can be a straight line with a ruler, but it can also be a smooth curve, but they're the only two options. It can either be a smooth curve or a straight line. So let me just look at these points. I can zoom in a little bit. Does it look like that these points here are going in a straight line? Not really. It looks like they're kind of curved. So because it looks like they're curved and that one's curved, I'm going to try to do a smooth curve for these points. And I don't have to go through all the points, but if I can go through all of them, that's even better. So in this one, okay, fair enough, I missed that. I probably could have drawn this one a little bit better, because it looks like this line could possibly go through all the points. But again, it doesn't really matter if they go through all the points or not, as long as we've got equal amount above and equal amount below. So now I've done the difficult bit, I can just do the thing that it says here. So just reading off the graph, I think that I'm expecting that I'm going to have to do for every graph question. So it says 4.6 Earth years. So I'm just going to zoom in here and be careful about my scale on my axis, because that's something that's going to trick me maybe. So I can see this one is 4 and this one is 6. So this one here is obviously 5.0, and it's telling me that the number I care about is 4.6. So what's it going up in? So it looks like it's going up in 0.2. So 4.2, 4, 6, 8, and then goes to 5. So 4.6 is going to be over here. So what do I have to do? I draw a straight line, and I should be using the ruler to this line over here. Where it hits that line, I'm going to draw a straight line down over here. And then I'm just going to read what this number is. Remember, you have to draw those lines on the graph, because the examiner wants to see evidence. You can get a mark for the evidence that you're taking readings from a graph properly. So then what is this number over here? Again, I've got to be careful with my axis. It goes from 400 to 500 million years. So it looks like it's going up in 20 million years. So that's going to be 420 million, sorry, not years, kilometers. So the distance is going to be, I'm going to write here 420, and then it already says millions of kilometers, so I don't need to do anything more than that. Now obviously with the graph questions, when you're sketching a line, there's differences because your sketch of a line might be different to my sketch of a line. So you're going to get 1 mark for any smooth curve that you've drawn on there. If it's a straight line, you're not going to get the mark. You get a mark for drawing the line from here, so this line that we've just drawn down to there, so that's a separate mark. And then the third mark is for actually reading whatever your number is. So even if your number is slightly different to mine, you get a mark for that reading. And the ones that they accept in the mark scheme are between 400 and 460 million years. So any of those are fine. So this is another content one. It's a 6-mark question, and this is for triple only. So what is it saying to me in here? It's talking to me about the Big Bang Theory, and it's saying it gives the explanation of the origin of the universe. And I've always got to do the same thing for all 6-mark questions. I'm going to break it up into however many parts I think I've got to break up into, and then make sure that I'm saying the obvious things for each part. So what is the key law, principle, or formula the examiner wants me to say for that part? What's the obvious thing I need to say for that part? Any keywords in it, and link it to the question. So how many parts is this one? It says how the Big Bang supports the idea that the universe is expanding, and supports the idea that the universe began at a single point. So what I've got to be careful about here is, because when I'm doing my revision, I know that there's the Big Bang Theory, I know there's steady state theory, and I know there's evidence for the Big Bang, evidence for the steady state, but this question is asking nothing about steady state at all. So the things that I know from my revision, I'm just going to do it in here. This isn't what you're going to do for this question, but it might come up in the real exam, is I know the 2 theories are Big Bang and steady state. And I know the 2 pieces of evidence are redshift and cosmic microwave background radiation. Okay, so if this was in the exam and it did say about both of them, okay, look, you can see there's 4 parts here. Okay, this is only 2 parts because I'm just doing the Big Bang part. Okay, so redshift, does redshift say anything about Big Bang, or would Big Bang say anything about redshift? Yeah, it does. Does Big Bang say anything about cosmic microwave background radiation? Yeah, it does. Does steady state say anything about redshift? Yeah, it does. Does it say anything about cosmic microwave background radiation? No, it doesn't. So if it was a real exam, I'm showing the examiner that I know this, but because it's this particular question, I'm only talking about those things. So I know that in my answer, I've got to talk about expanding and began at a single point. Now the expanding, that's the redshift. So the reason why I know the universe is expanding is because of redshift. So again, if it comes up in the real exam, both of these theories say it's expanding, but I only care about Big Bang here. So for the expansion part of it, the first thing that I'm going to do is show the examiner that I know I'm just going to use the keyword redshift. Okay, now obviously I've got to show the examiner that I know what is meant by redshift. So what is meant by redshift is the light from distant galaxies, and make sure I'm saying galaxies here because some students will say stars, and that wouldn't get you the mark. It has to be galaxies. So the light from distant galaxies has a perceived increase in wavelength. And again, I'm going to make sure that I'm saying perceived because the actual wavelength doesn't increase, but when I'm measuring it from Earth, it does increase, and it's got to be wavelength that I'm saying. It's got a perceived increase in wavelength. That's it. So that's what redshift is, and it's an example of a Doppler effect. So because that's another key word in there, I might as well just put that in there. That's an example of the Doppler effect, Doppler with capital D. Okay, so then how does this prove that the universe is expanding? How can I link this to the question? It keeps on changing my thing. I'm just going to write it neatly here. Doppler effect. Okay, now is there anything that I can say about this? Anything more than I can say? Well, it's called redshift. The increase in wavelength. Red has got a longer wavelength, so it goes to the red end of the spectrum. So I can be saying that in here as well if I wanted to. And in your exam, you probably should do that. So if there's an increase in wavelength, that shows that the galaxy is moving away. And again, I've got to make sure that I'm saying galaxy, because if something is moving away from us, there's a perceived increase in wavelength. If something is moving towards, there's a perceived decrease in wavelength, which would be blue shift, but this galaxy is moving away, so it's going to be red shift. Now, how does that show that the universe is expanding, I've got to say that all galaxies are moving away. I could say most as well, but I mean, that's more A-level kind of thing. So all galaxies are moving away. Now, what's the only explanation for everything moving away? If everything is moving away from me, the only reason for that can be is because the universe is expanding. So I've said all galaxies are moving away, therefore the universe is expanding. So there's evidence for the universe to be expanding. So it's the galaxies that are moving away and the universe that's expanding. Make sure that you are getting those terms right in each part. So I've said the expansion part of it now. I've got to obviously mention the began at a single point. So how do I know that the universe began at a single point? So just like I used the key term straight away for the expansion one, I'm just going to use the key term straight away, CMBR. And now I'm going to show that I know what is meant by CMBR. So that is the radiation coming from everywhere, coming from all directions in the universe. And it's coming equally. So I'm just going to show that I know that. Okay, well, because it's called microwave background radiation, I'm going to say that the wavelength is in the microwave region. I don't know why my pen keeps on doing that. Is in the microwave region. Okay, is there anything else that I can say about it? Well, why is it in the microwave region? The reason is because it's been redshifted from the beginning of the universe. So redshifted from the short wavelength or high energy photons at the beginning of the universe. And the fact that this has happened and the fact that it's coming from everywhere equally shows that, so it's just the fact that it's coming from everywhere equally means that the universe must have begun at a single point. And now I've said enough about both of those things. So I know that, yeah, I'm going to get 6 marks for this one. I've done my content revision. I've remembered all of these things properly. Yeah, I've definitely got 6.